Hello everyone, my name is Chris Dale, and this is my project. Here we can see that I have been working on a Dungeons & Dragons map utilizing the microbit and electronics to help give it some really cool augmented features. The idea was that I wanted to make a robot that was a thing that could be utilized by my students in their day-to-day lives. So how could you take microbit and, as a really nerdy student who absolutely loves Dungeons & Dragons, utilize it for Dungeons and Dragons? And this was what I came up with, was, making different sorts of map pieces and things. I've made a whole variety of different components that highlight different engineering features and different sorts of things like that. I had a lot of fun. I made like little fountains and altars, bridges, moving staircases. Like I carved a flame out of styrofoam. I made little stockades and castles. Here we can see that I created a housing for the microbit and to keep all the wires from getting tugged on. The overall project utilized little figures and larger figures to sort of represent the two scales of types of creatures, like human beings and giants. You can see that there are various LEDs that I utilized. That's an RGB LED, and here we can see a little button. Those buttons help to influence the overall motion of the different components. For instance, here we can see a servo that's attached to an arm that a character could climb onto the outer platform of. Over here, we can see that there is a button that is underneath a weird little H-shaped statue. And there we can see sort of like a little gondola, maybe, a bit like a Ferris wheel. It is utilized to lift characters up from the bottom part of the map up to the upper part of the map. Over there, you can see various styrofoam pieces that I created to represent some different sorts of cool things. And overall, this is sort of the general layout of what the project looks like. Here we can see what happens when I press the different buttons. The little H-shaped altar button, when pressed, will move around that arm. And then if we move over to the other side, we can see that there is a staircase attached to a servo, and we can see that we have a little button that is underneath what looks like a couple of arrows pressing down, maybe an indication to press the button. As you can see, it does mess up the appearance of the LED when I press it, but as I press that button, it will allow the setting of which position the servo should be set to change in the programming of the microbit. Here we can see what happens when I press both of these buttons at the same time. It allows the Ferris wheel arm to move, or lift arm, whatever you want to call it. There are 3 different places it goes to. One is close to the ground, one is in the middle, and one is on the other end, and one is a random position going back down the other direction. So it will stop once at a random position going down. Down there you can see the light of the microbit. Let's see if I can carefully lift up everything and show you guys what happens with the microbit in reference to the RGB LEDs. So there are the RGB LEDs. Oh no. Okay. All right, everything's fine. Here we can see the microbit. Those 3 LEDs there are changing in brightness with relationship to the red, the green, and the blue values that are expressed in the RGB LED. There's also a resistor right there. That was used to ensure that the red LED in the little flame that I carved didn't burn itself out, because it is a lower power LED than the other LEDs. So that's the overall makeup of the project. Now we're going to specifically look at the robotic parts of the project. So here is where I hid the microbit down in the bottom there. I mounted the breadboard upside down. Those wires are attached to the breadboard. These two connect to the LEDs. The bottom is a RGB LED and the top are two regular LEDs. On either side there, you can see the two buttons that I created, and then in the center, you can see the other two servo creations. One is a moving staircase that has the servo mounted upside down and allows the staircase to be twisted side to side. That little lifted up portion allows the staircase to have that gap bridged. As you can see here, we have the other servo that is attached to a small arm made of craft straws. This is one of the buttons. You can see there that I created my own little circuit board utilizing some soldering. I was able to put the button in there. And for this other one, I was also able to include a similar button underneath an H-shaped piece of styrofoam that I carved out of some old packaging. Here we can see what happens when I press those different buttons. The buttons on the micro bit allow me to see what would happen if I pressed the other remote buttons that I created. These different lights that are lighting up represent the first, second, third, and 0th positions. And then you can see what happens when I press both. It's going to turn on the servo. Now we're going to take a look at some of the other components that I've made. I utilized a wide variety of different pieces. There are the figurines. Here is the castle. That was actually the first bit that really inspired the rest of the project. I was just working on that for fun initially. And then I realized that, well, I could really turn it into a project that would be able to be utilized for class. And so I, kept working. I made a whole bunch of different pieces. I started to think about how I could integrate STEM into it. And here we can see that this is actually, it's the beginning of a representation of a historically accurate forge. It is not currently historically accurate. I would need to research it more. But the idea here is that these students would be able to create things out of styrofoam that might actually represent different sorts of past actual structures. Here we can see that this is a little piece of engineering that I'm pretty proud of. I love building these sorts of things. This is a piece that is utilizing compression and tension. So the paper and the hot glue stuck to that paper will allow one side to have a pretty good tension strength. The other side is made of styrofoam, and styrofoam is strong under compression. And so that allows it to be springy. Here we can see something that's very stable, even though it has a very sort of an uneven sort of a shape. It's lots of strange angles. But the overall idea here is just that it's having students work with shapes such that they're able to figure out, oh, I can make something flat on top of a weirdly angled something by figuring out where the sort of perpendicular to the slope is. This is a stockade. It's supposed to sort of represent maybe a historically accurate stockade. This is, again, calling out to different sorts of STEM, integration projects with other sorts of disciplines in school. here we can see I've made a wide variety of different little challenges and components to it. I even included like a little ladder on the inside of the castle to allow people to climb down into the dungeon area. Some of the different engineering features are like this one, where we can see that utilizing the strength of triangles, we are able to compare a non-triangular side to a triangular side. So one side has a nice strong triangular leg and the other really doesn't. Here we can see the benefit of triangles used as a beam, and this beam then becomes a bridge. That bottom tip of the triangle with the hot glue protrudes out enough to actually catch on the table, have some friction, and it is able to be stood up like a ramp. Here you can see a little sort of homage to Stonehenge. It's definitely not 100% accurate with relationship to the different henge stones, but that is sort of the overall idea. These could be representational of different historically accurate pillars. And these two pillars are, one is sort of representing an aged pillar, one's representing a sort of a new pillar. And I thought it would be sort of an interesting thing if students were talking about weathering of stone. Here we can see utilizing tension, compression, and triangles all in one little model. I also used some different scraps of paper, some glasses, and an old Dungeons and Dragons map that I drew up for a campaign that I was running for some students. Had a lot of fun with that. So here we can see that I used the RGB LED and the little flame together with another piece with a craft straw stuck in the top. The idea here is just that, maybe Santa Claus can't come to everyone's apartment, and so having the ability to create a project that would, say, allow Santa Claus to come to your apartment, or maybe you could do this in a different form, create a menorah that doesn't use flames, instead uses circuits being completed to light up the different components. And have a nice day.